Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing implementation of multiplexer. The topic is from combinational logic circuit. The subject name is digital electronics. In this class we will be solving two problems on multiplexer. Coming to the first question, first problem is implement 16:1 mux using 4:1 mux. Using 4:1 mux, we have to implement 16:1 mux. So, before the start of the problem, you must understand 16:1 mux will have 16:1 mux will have 16 inputs, that is from D0 to D15, and it is having one output. 16 can be written as 2 to the power 4. So, it is having 4 selection lines. They are S0, S1, S2, S3. So, 16:1 mux is having 16 input lines D0 to D15, one output line and 4 select lines S0, S1, S2, S3. Okay. So, here we have used 5 4:1 mux. Okay. One, 2, 3, 4. This 4:1 mux. 4:1 mux means it is having 4 inputs, D0 to D3. It is having the inputs from D4 to D7. The third mux is having D8 to D11. And the fourth one is having inputs from D12 to D15. So, how the inputs are? It is starting from D0 to D15. So, 16 inputs are there. For this 16 inputs, we need only one output. So, the output of this mux Y1, the first mux output is Y1, second mux output is Y2, third output is Y3, fourth output is Y4. So, these outputs are now acting as input to the next 4:1 mux to generate a single output. Okay. So, 16:2 mux is clear now. 16 inputs D0 to D15 using 4:1 mux, and these 4 outputs are then given to single 4:1 mux to get single output. Now, coming to selection line, each 4:1 mux will have 2 select lines. Okay. So, 2 select lines are common to this 4 mux. For these 2 mux, we have given S0, S1, S0 and S1. 2 select lines are given for these 4 mux, S0 and S1. So, 4:1 will have 2 select lines, and now this the output mux will have 2 select lines. They are S2 and S3. So, how many select lines are used here? S0, S1, S2, S3. 4 selection lines are there. Okay. So, this is a 16:1 mux having 16 input lines D0 to D15, one output line and 4 selection lines S0, S1, S2, S3. Okay. This is how we have to implement 16:1 mux using 4:1 mux. I hope this solution is clear. Coming to the next question, next problem is implement even parity generator for 4 input using multiplexer. So, we have to generate an even parity using how many inputs? 4 bits. So, let us first write the truth table of the even parity generator. So, 4 inputs are to be taken. We have taken it as A, B, C, D. So, for 4 inputs we can write total 16 combinations. 2 to the power 4 is 16. So, we have written the inputs from 0, 0, 0 till 1 1 1. So how do we write that? 0 0 0 0 0 0 0 1 0 0 1 0 0 0 1 1 0 1 0 0 0 1 0 1 0 1 1 0 0 triple 1 1 triple 0 1 double 0 1 1 0 1 0 1 0 1 1 1 1 double 0 double 1 0 1 triple 1 0 triple 1 0 and then 4 ones. Okay, so we have written this truth table starting from 0 0 till 4 ones, 0 to 15 we have written 16 possible combinations. Now how this output column is to be written? It is to be even parity generator. So we have given the output variable name as here P. So it should be even. The number of ones including the parity, if the input is an odd, we have to generate an even parity. So we need to add 1. So here all are 0, so no need to add 1. So it is 0. In this combination 0 0 0 1, now this combination is having odd number of ones. We need to generate even parity. So we will add 1 here to make the number of ones in the combination even. Now in this input number of ones is only 1 odd. So we need to add 1 here. Here double 1 means no need of 1. So it is written as 0. In this combination it is only single 1 is there. So we will add one more 1 here. So here in this 1 0 1 combination 2 ones are there. So no need to, it is already even number of ones are there. So no need, we add 0. Double 1, no need, so 0. Triple 1 means odd means we need to add 1 here. So for 8, 1 triple 0, so it is having odd number of ones, we need to add 1 here. 1 double 0 1, so it is having 2 ones, so 0. Double 1 0, triple 1, 3 ones means odd, so we need to make it even. So we will add 1 to it. So number of ones are 4 even. Here 2 ones even, so 0. 3 ones we will add 1. 3 ones we will add 1. So whenever there are odd number of ones, we need to make them even by adding one more 1. Okay. Here all are 4 ones are there. 4 ones means even, so no need. So we will put a 0 here. So now looking at this column of parity, column, we need to write the function of variables a, b, c, d. What are the list of minterms having 1? Here it is 1, for 2 it is 1, 1, 2, 4, 7, 8, 11, 13 and 14. So in this output column we find that these minterms are having ones. Okay, so we have listed the list of minterms as 1, 2, 4, 7, 8, 11, 13 and 14. At these places output is 1. Now we need to draw an implementation table. We need to draw using multiplexer. We are using 8:1 mux here. So we have taken 8 inputs D0 to D7, D0, D1, D2, D3, D4, D5, D6, D7, 4 variables. So first variable is used in the implementation table A bar A. So this is the outer structure D0 to D7 A bar A, and inside this implementation table we need to fill the numbers from 0 to 15, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. After filling this 15 numbers, need to circle what are there in this list of minterms. What is there? 1, 2, 4, 7, 8, 11, 13, 14. We have circled them which are there in this list of minterms. How did we get this list of minterms? From this truth table where ones are present, we have listed it here. So, you know how to read the column. In D0 column, the bottom is circled, so it will be A. Here in this D1 column, the above one is circled, so it is A bar. Above one is circled, so it is A bar. Below one is circled, so it is A. Above one A bar, below one A, below one A, above one A bar. So, we observe that D0 is connected to A. Now, let us see how to draw the implementation table, implementation diagram of 8:1 mux. Logic diagram. So, 8:1 mux will have the inputs from D0 to D7. Now, we have taken this line A, the output of this will be A bar. Okay. So, you observe here D0 is connected to A. So, D0 is connected to A. Then D3, D0, D3, D5 and D6. D0, D3, D5 and D6 are connected to line A. Now, the remaining one, that is D1, D2, D4 and D7 are connected to A bar. So, they are connected to A bar here. So, in this way the 8 inputs of 8:1 mux are connected based on the outputs of the implementation table. D7 is connected to A bar. So, D7 is connected to A bar. 8:1 mux will have 3 selection lines. We are having 4 variables A, B, C, D. A is used in the implementation table. A, B, C, D. A is used in the implementation table. These 3 variables B, C, D are used. 8:1 mux means 8:1 mux means 8 input lines, 1 output line. 8 is 2 to the power 3. So, 3 select lines. 3 select lines are B, C, D. So, B, C, D are taken as 3 select lines. So, this is how we have implemented even parity generator using 8:1 mux. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.